Hello, I'm Eric. I'll present a data-driven project aiming at improving the revenue of a cafe. This project focuses on understanding customer behaviors, identifying patterns that influence spending, and addressing key factors that impact customer retention and churn. By leveraging analytical techniques and strategic insights, the goal is to make informed decisions that that can enhance the cafe's revenue. And in and in this project, our primary objective is to understand customer purchasing patterns, such as order frequency and average order value, which are the most important factors for a retail business. Through this analysis, we plan to uncover opportunities for targeted promotions, improve inventory management, and suggest personalized customer engagement strategies to boost sales and customer satisfaction. And in this project, the data is stored in Google Cloud BigQuery. The dataset consists of several important columns that provide insight into customer behaviors and sales performance. And first, we have order ID, a unique identifier for each transaction, and customer ID refers to the customer making the purchase, allowing us to analyze customer-specific trends and behaviors. And date paid help us understand the timing of orders, and represents the total amount spent in each order, and status tells us whether the order was completed or cancelled, and items help us identify the items purchased in each order. And in this project, my research process follows a structured approach. First, I began by analyzing customer behaviors that could potentially impact sales. These behaviors might include order frequency and average order value. Next, I compare the correlation coefficients between different customer behaviors and their total spending. This helps me identify which behaviors have the strongest influence on total spending, allowing me to focus on the most impactful factors. And then I applied a Bayes theorem to select high-risk products, those that have a significant chance of impacting sales negatively. Based on these insights, I designed specific strategies to address the identified and to address the challenges and opportunities. Then I evaluate the trade-offs of the business strategies, weighing the potential benefits and risks to determine whether the strategy should be implemented. And in this step, I calculated the correlation coefficients between order frequency and total spending, as well as between average order value and total spending. By comparing these correlation coefficients, I found that order frequency has a stronger correlation with total spending. So this suggests that customers who purchase more frequently tend to spend more overall, highlighting the importance of increasing purchase frequency as a strategy to boost sales. And to further validate the relationship between order frequency and total spending, I performed a hypothesis test. And after conducting the test, I obtained a p-value of 0, which is far below the typical significance threshold of 0.05. This means we can confidently reject the null hypothesis and conclude that there is a strong linear relationship between order frequency and total spending. And the most important factor affecting order frequency is customer retention. And customers who make repeat purchases have a higher total spending. Therefore, evaluating how well each product retains customers becomes the focus of the next phase of my research, where I will explore strategies to enhance customer retention and drive greater sales. And to measure each product's ability to retain customers, I needed to label the status of customers after each purchase as either retained or lost. So I built a customer churn threshold model to compute a churn threshold for each unique customer. To determine the threshold, I first compute the number of days between every 2 consecutive purchases for each customer, then calculate the mean and standard deviation of these intervals for each customer. We set the churn threshold for each customer at 1 standard deviation above their average purchase interval. For each customer's orders, if the number of days between the current order and the next order doesn't exceed the churn threshold, the current customer status is labeled as retained, and the next order is considered a repeat purchase. Otherwise, the current customer status is labeled as churn, and the next order is classified as a new purchase. As shown in the table, the interval 9 is greater than the threshold 7, so the status in last purchase is considered as churned. And the interval 2 is less than the threshold 7, so the status in last purchase is considered as retained. And to investigate whether buying a specific product would result in a repeat purchase, for each product, I used Bayes' theorem to calculate the probability that a customer will make a subsequent repeat purchase, given that they have purchased a specific item in the current order. And P-repeat is the probability of the next order being a repeat purchase, which equals to total number of orders with a subsequent repeat purchase divided by total number of orders. And P item is the probability of purchasing the specific item, which equals to total number of orders for the item divided by total number of orders. And P item repeat is the probability of purchasing the specific item, given that it leads to a repeat purchase, which equals to number of orders for the item divided by the total number of orders with the subsequent repeat purchase. Substituting these factors into the Bayes' theorem, we derive the following equation. The probability that a customer will make a subsequent repeat purchase, given that they have purchased a specific item, is equal to the ratio of the number of orders for the item that leads to a repeat purchase to the total number of purchases for the item. And based on the calculations, I identified 10 products with a very low probability of retaining customers. These products consistently underperformed in driving customer loyalty, making them a focus for improvement. And to ensure the statistical reliability of the results, I excluded products with total sales below 30 units, as their low volume makes it difficult to draw meaningful conclusions. Given these findings, the next step is to evaluate whether these high-risk products should be removed from the menu to improve overall revenue. And in this step, I conducted a trade-off analysis to evaluate the impact of removing the high-risk products. The analysis considers 2 key factors: lost loyal or targeted customers versus recovered churn customers. A loyal customer for a product is defined as one whose total spending exceeds the median spending for that product. If the value lost from loyal customers is lower than the benefits gained from recovering churn customers, then removing the product is justified. And after removing the high-risk products, the next step is to estimate how many customers we can recover. And this shows the number of customers that can recover. And the number of recovered customers is calculated by multiplying the product churn probability by the number of customers associated with that product, then multiplied by the overall retention rate of the cafe, which reflects the probability of winning back customers across all products. This approach can estimate how much customer retention can be regained after removing the low-performing products. However, Simply calculating the number of recovered customers after removing those high-risk products isn't enough. We must also consider the spending behavior of loyal customers who are lost due to the removal. To address this, we use lifetime value to measure the overall contribution of each customer. And the revenue trade-off is calculated as the number of recovered customers multiplied by the overall customers' lifetime value minus number of loyal customers multiplied by the lifetime value of targeted customers. And this difference gives us a clear picture of the financial impact of removing a product. And LTV, lifetime value, estimates the expected revenue from a customer by multiplying their average monthly spending by the average time they stay as a customer. A lower churn rate implies customer stays longer, contributing more to the lifetime revenue. According to the table, some values turned out to be negative, indicating that the loss caused by loyal customers leaving outweighs the benefits brought by recovered customers. Therefore, these products shouldn't be removed. And the final step is to estimate the additional revenue that removing these high-risk products can generate. The formula for calculating this is additional orders multiplied by average value per order divided by original total revenue. And here, additional orders are derived using the summation formula of geometric sequence. We assume that the recovered customers will continue to make repeat purchases based on the cafe's overall retention rate. By combining the additional orders with the average value per order and comparing it to the original total revenue, we can quantify the revenue impact of these changes. So this analysis can provide a clear financial incentive for removing those high-risk products. Okay, thank you for listening, and I'm here to answer any questions.